Today we're going to look at solving triangles. This seems to be the way we're finishing our trigonometry. So one of the biggest ideas in solving a triangle, as it's been all the way along, is the idea of making sure you draw the picture, label everything you know and want to know. So this question right here is basically asking, what is the width of Garibaldi Lake? And what you should notice right away is the picture looks like we have an obtuse triangle, and we do. So what we're told is this helicopter is flying 1,610 meters above the forest, and that's always vertical. So here's what that's saying, that this distance from the helicopter to the ground is 1,610. And what we want to figure out is the width of the lake. So by looking at this picture, what I hope you recognize is you have an obtuse triangle. Obtuse, remember, means greater than one angle greater than 90 degrees. So this problem turns out to be a two-step problem, and I'm going to look at it in two different ways. First of all, I'm going to look at it in the case of if I could figure out information about the big triangle and information about that little sliver of a triangle, then I can figure out how long the lake is. So my strategy in solution number one is figure out this distance from here to here, figure out this little distance here to here, and then subtract one from the other. So that's going to be my strategy for this first solution. So what I need to do is to redraw my picture, but here's going to be my big triangle, and then I'm going to do that little sliver of triangle. So when I make my big triangle, here's what I know. I know that this angle right here, or this side right here, is 1,610. I know this angle right here is 45. And again, the reason I know that angle is 45 because I know this angle right here is 45. And I know that that is a 90-degree angle in sum. So I know 45 plus 45 is 90. And what I now want to figure out is I want to figure out this distance across the bottom. And I can do that quite easily because I can use my grade 10 trigonometry, the tangent ratio. So I'm going to go ahead and I'm going to write the tan of 45 degrees is equal to opposite over adjacent. And we know how to solve that. We multiply both sides by 1610, and we end up with x is equal to 1,610 times the tangent of 45. And when we plug that into our calculator, we get 1610. So this big distance from here to here is 1,610. And now I just want to figure out this little distance right there. And what I could use to do that is I can use that little sliver of a triangle. Again, I know that this is 1610. I want to figure out this one right here. I'll call it y this time. And just like we did before, if this whole angle from here to here is 82, then this angle right here has to be 90 minus 82. It has to be 8 degrees. So that angle right there is 8 degrees. And again, I hope you see that you have the tangent ratio. The tangent of 8 is equal to opposite over adjacent. Multiply both sides by 1,610. Get out my calculator, push the buttons, and my calculator spits out 226. And remember, that represents this little piece right here. So the lake is equal to the bottom of the big triangle minus the bottom of the little triangle, and what we get is 1384 meters. So there's one way to solve the problem. Another way to solve the problem is a little bit different. It's figuring out something about the little triangle first, and then the big triangle second. Well, we're going to do the obtuse triangle. So again, the idea is this time we're going to do triangle number 1 first and triangle number 2 second, because in triangle number 2, right now, it looks like I have absolutely no information. But with using the sliver of a triangle, what we can do is we can figure out this side right here. And then what I'm going to do is I'm going to go back to that side right there, and we're going to figure out this angle right here, and we're going to be able to use the cosine law. So let's go ahead and do that. Let's look at the sliver first, and remember we already know this is 8 degrees, and we already know this is 1610. But here's what I want to do this time. I want to figure out side Z. And what I know in my 90-degree triangle is adjacent and hypotenuse, and that points me to the cosine ratio. So the cosine of 8 is equal to adjacent over hypotenuse, and hopefully we remember how to solve this. We interchange these two. Z is equal to 1610 over cosine of 8. And when we punch that into our calculator, we get 1,626. So in my big triangle now, which is an obtuse triangle, I know this is 1626. Now, I'm going to tell you this side right here. This side right here is equal to 2,277. And the way we got that side is we used Pythagoras, or I did, but I just don't want to do it right now. We used Pythagoras to figure that out. 1,610 squared plus 1,610 squared is equal to that squared. And when you do that calculation, it's 2,277. So I want to figure out, remember, here's the lake. This is going to be the actual lake right here. And we need to figure out that sliver of an angle up top here. And again, that's pretty easy to figure out, because this angle right here, right there, is equal to 82 minus 45. And 82 minus 45 is 37. So our angle is 37. And now I hope you see that we're going to use the cosine ratio, or cosine law, sorry. So I'm going to call L, lake L. L squared is equal to, I'm just going to plug it in. And a nasty looking expression, but thank goodness we have a calculator, because when we punch that into our calculator spits out this really nasty number, and then we take the square root of that nasty number, and look at what we end up with. The same answer as before. So again, big ideas, draw yourself a picture, have a plan, write down what you know, and do lots of calculations. So again, here's an example of if you didn't draw the picture, you wouldn't recognize that there's two possible answers to this. So have a read of the question and draw your basic picture. So here's what your basic picture should look like. Here's like this bottom, and we have two sides of a canal, and one of them is at 49 degrees, and the other one is at 28 degrees. And given that, I know this angle right here is 103 angles on a line, and we're told that one of the slopes is equal to 12, and then we're asked what's the water width of the surface when the canal is full. So in this example right here, what I'm going to do in the picture I've just drawn is I'm going to imagine that this is 12. And if that's 12, then the canal will be full, and that's what it'll look like. And what we're going to want to figure out, again, I'm going to call this A, then this is going to be little a. So in this picture right here, that's what the picture looks like. If the canal's full, it can only go as high as one of the sides, and away you go. Well, the other picture would look like this. What happens if the other side is 12? So again, I'm going to draw my canal. There's my 49. Except this one right here is going to be 12 this time. So again, that's 12 this time. This is our 12. This is our 28. And again, if this is full, this is what it looks like. Remember, this is still 103 angles on the line. We'll call this angle A. And here's what those two pictures look like. So it's understanding a story. Now, given that we have the story, what I want you to see is, well, we actually do have a matching pair. And the matching pair is that side to that angle. And the matching pair right here is this side to this angle. So you should understand that you actually have that top right angle in case number one and the top left angle. And this angle up here is 28 degrees, and this angle right here is 49 degrees. And the reason for both of those is alternate interior angles. And we know that alternate interior angles are the same. So you can't forget that stuff we learned earlier on in the year. Now that we have our matching pair and we have our other piece of information, what we can go ahead and do is we can do our sine ratio. So A over sine 103 is equal to 12 over sine 28. And again, we're going to multiply both sides by sine 103. And we're going to push our buttons on our calculator, and we're going to get 24.9. So the width is that many meters. This one over here, same idea. Little a over the sine of big A is equal to 12 over the sine of 49. And again, we're going to multiply sine 103 to both sides and push the buttons on our calculator, and we're going to get 15.5. 15.5. So again, draw your picture, label your picture, imagine the problem. So one last one. It's not a do a calculation, it's can you do the calculation. So here's the story behind this. You're on the opposite side of a river of a tree and you know certain information, and this actually can be done physically. And the question is, does Bert have enough information to figure out the height of the tree? So let's do the back logic. We're going to assume that the tree is at 90 degrees to the ground. So in this question right here then, if I could figure out this side, or if I could figure out this side, then I have an angle and a side, and I could figure out that height of that tree. So the easiest side to figure out would be this side right here, the bottom side. And the reason that's the one we need to figure out is it's actually a shared side. It's a shared side of the vertical triangle. It's the base of the vertical triangle, but it's this side of the flat triangle. And in the flat triangle, we have three angles, or if you want to do it another way, we have two angles and a side, and we can go ahead and solve for the bottom triangle, figure out that shared side, the gray arrow, and then use our basic trick. So I'm going to summarize that for you, but make sure you can follow the logic. In order to find the height of the tree, again, we're going to assume it's at 90 degrees. But honestly, that wouldn't matter either. expert would need to know the distance from A to the base of the tree or to the top of the tree. And as we know, all three angles in the flat triangle, so again, the one that's on the ground, we can determine the distance across the river. To the base of the tree. Then we can determine the height. So again, we have to jump through a few hoops. But if we understand the physicality of the problem, or if we draw ourselves some triangles, it makes it a lot easier to solve these problems.